So, homework 6, color wavelength. Electromagnetic radiation, such as visible light and X-rays, has properties based upon the wavelength of the radiation. For example, a visible light has a wavelength between 415 and 495 nanometers. What is a nanometer? It's 1/1000th of a meter. It'd take 1 billion nanometers to make that. Then it's blue. And if it's between 620 and 750, it's red. Where do you get these numbers? I'm getting them here. So, the colors are related to wavelength as shown in the following table. So for this purpose, we can ignore the frequency and the photon energy columns. All we care about is the color and the wavelength columns. Now, wavelength can be calculated from frequency and vice versa, but decided not to make you all do that. So write a program that will ask the user for the wavelength of light in nanometers and then display what the color it would be. If the value is between 380 or 750, it is not visible light, right? If it's lower than that or it's above 750, it's not visible light, and your program can say that. And so when writing your if statements, make them inclusive on the bottom and exclusive on the top. In other words, the column that says 450 to 495, make it say if x is greater than or equal to 450 and x less than 495, right? It'll be greater than or equal to the bottom one and just less than the top one. That way you don't have to worry about what the division is, right? Is 450 considered violet or blue? Is 570 considered green or yellow? By what we just said, the lower boundary is inclusive, so if it's 450, then it's actually blue, so you would make it less than 450. If it's 590, then it's not yellow because yellow is only up to 590 but not including 590, then it's orange. And so that's what my final little statement here. When you write your if statements, if it says that to that, then make the 450 inclusive and the 495 non-inclusive. If wavelength greater than equal to 450 and wavelength less than 495. Okay, so you can do that one if you want. It's optional, or the other one's optional. Do both, get extra credit. So a menu-driven program is one that presents you a menu, and it does something based on that menu. You know, press A for something, press B for something, press C for something, or press Q to quit. That kind of thing. And so you list your menu choices on the screen. Menus can easily be implemented using if-else-if statements. And usually you wrap them in a loop so that it'll keep repeating over and over and over. So what we're going to first do today, it is a really simple, short little program, is we're going to write a little menu-based program that just lets us double a number or add to a number. So it's going to look like this when it runs. You know, choose A to add, press D to double, or Q to quit. That's what it's going to say. And so the starting value is going to be 1. So value is equal to 1. And then we're going to type in A, and it'll add something to it. Right? It'll add 2 to it, something like that. Value will then equal 3. And then we press D, and the value is going to double. Value is equal to 6. If we do D again, the value is going to equal 12. If we do A, then it's going to add 2 more to it, and the value is going to be, 14, something like that. Or maybe we could even ask them how much we want to add to it. But that's the idea. That's what it's going to do. And then if they ever choose quit, goodbye, like that. So we're going to structure that in the form of a loop. And as long as they haven't chosen Q, then we're going to do what they pick based on an if statement, right? If their choice is equal to A, we're going to do one thing. If the choice is equal to D, we're going to do something else. Now to get this going, we're going to have a variable declared outside the loop that holds our initial starting value of 1. Or maybe 0. Figure that out. And then inside the loop, we'll have an if statement. If choice is equal to A, then we're going to add 2 to the value. If choice is equal to D, we're going to multiply the value by 2. So it's going to be a pretty short little program. Then we're going to make a larger menu-based program that sets up the homework. So why would we want all of our menu-based programs to loop? What would be a reason to make our menu-based program loop?
So the program doesn't just close?
Right, you know, they choose to do one thing and it ends instantly. Yeah, that'd be kind of boring. Maybe that's what we want, but more likely we want it to let us continue to pick options until we finally decide when to quit. All right, I'm going to grab my boilerplate, create a new file, paste it in. Today is Lecture I. We've finally gotten the monitor fixed. Lo and behold, we're not missing that last half inch. Okay, so we're going to need a variable to hold our value. Double value is equal to 0. And we need a while loop. We need a choice. Let's maybe store our choice in a string. String choice. And while, we better initialize it with something. So string choice is equal to quote, two double quotes. Quote, quote. While choice is not equal to quote q end quote, double quotes. So while choice not equal to q, then let's print out a message and let's get our input. So cout, A for add, D for double, Q for quit. Colon, space, end quote, semicolon. And let's read that in. C end into choice, CIN arrow arrow choice, and we'll just have a if statement. If choice equals quote A, then value plus equals, let's just make it plus plus. We'll add 1 to it each time. Else if parentheses choice equals D, value times equals 2. Else if, and we don't really need this one, but if choice equals Q, then let's just see out a message, okay, done. Backslash n, end quote, semicolon. And we're going to put one final dangling else, one trailing else to handle anything else. Else, cout, that option is not supported. Backslash n. And then let's print out the current value. Or should we print out the value before or after? And let's print it out here. So up at the top of our loop above A for add, I'm going to print out cout arrow arrow current value colon space end quote arrow arrow value arrow arrow ENDL. Okay, so if I double 0, it's still going to be 0 afterwards. So I have to add 1 to it before anything starts to happen. Now I can double it. And if I type in something unrecognized, it should give me an error message. That option is not supported. Okay, so that seems to be working. One thing we could do is we could have a menu-based program where each time you choose something, it calls another function. We could go and we could add different functions to our code, and then that menu would choose it, would execute it. I don't see a real reason to demonstrate that here, especially since we haven't talked about functions all that much. So I'm going to leave this alone as is, make sure that everybody gets it. You understand what a menu-based program is, though. We're not going to have to hammer this in too much. So if we wanted to, we could add more options, right? H for half, I don't know, T for triple. Let's do that. Let's tack on T for triple. That's a silly syntax, isn't it? And then go and add another choice down here to handle tripling. And so tripling will just be value times equals 3 rather than times equals 2. So I'll let y'all do that. Go ahead and work on that. So to do a triple option, I would just add my menu option there. I added some text T for triple. And then in one of my else ifs, I would not want to put it down here at the bottom, right? That'd be bad. But, yeah. Else if choice equals T, then value times equals 3. Like that. Okay. And we could keep coming up with silly options, but I think that's enough. What I would be interested in doing is demonstrating nested menus, where after you choose one menu, it pops up another menu. So we're going to add one more choice here. Underneath this cout, we're going to add one more cout, or S for submenu. Now we don't even have a submenu function. I don't want to take it any further than that. Just delete that. We'll come back to that idea at another point. Get rid of that. Okay. What I was going to do is I was going to write another function, and I was going to have that one call this one. I think it would be a worthy exercise, but we're going to save that. So what you do is you display a list of numbered or letter choices. You prompt the user to make the selection. You test the user selection. And if you get a match, you execute that action. If not, you go to the next expression. So validating user input. That's inspecting input data to make sure it's acceptable. Bad output can be produced from bad input. So there's various ways you can test, right? You can make sure that a number is within a certain range. Reasonable, well, whatever that means. That it's a valid menu choice. We did kind of do that one. Or we can stop divide by zero errors. So for example, well, this isn't a very big example. If we're going to check, if we ask a user, if we're writing a program that's supposed to be, monitoring a patient's temperature, then there's probably ranges of temperatures which are, acceptable and unacceptable, right? If somebody's temperature drops below a certain value, then you could consider them dead. Or if it's above a certain point of value, then life, would not be possible. So when we ask somebody for their temperature, then we might set out a range of acceptable values. And we might say that if the temperature is less than 90 or greater than 110, we're going to prompt them again, or at least ask them, are you really sure? We would check. That's kind of doing a reasonableness check. The way that they've listed these, they make it look like two different things. But, if something is within a specific range, it's a good value. If it falls outside of that range, it's not a good value. If you're asking, for somebody's age, well, in these days, people live to be more than 100, but they don't live to be more than 130 or 150 or 200, so you could make, an upper limit, something like that. And if the user accidentally types that, you would, let them know that they got it wrong, and you would give them another opportunity to type it in again. Or the valid menu choice. And divide by zero, well, we check to make sure that we're not dividing by zero, because dividing by zero generates an exception that stops the program from running if you're doing integer math. Let's just prove that to ourselves. Let's make the very first line of code up here. Cout, arrow, arrow, 1 divided by 0, arrow, arrow, ENDL, like that. Well, that didn't work. Build errors. It's telling me. It's not even letting me compile it. It knows that it's dumb. Okay, well, thanks. That's a little bit too clever. Alrighty, how about this? Int x is equal to 1, comma, y is equal to 0, and then int z is equal to x divided by y. That will blow up. When we run it, it says unhandled exception. So I'm going to hit break, and then I'm going to hit my little stop button under debug. Debug, stop debugging. Okay. So if you were trying to figure out some calculation that involves integer division, then when you get to the point where you're doing that division, you'd better make sure you're not dividing by 0. Now, interestingly enough, floating point division doesn't generate an error like that if you divide by 0. If we change these ints to floats, then we're not going to see the same exception. You're not going to like the output, but you're not going to see that exception. So cout z equals, end quote, arrow, arrow, z, arrow, arrow, ENDL, right? We're just going to see the result of our little math there. And here's what it says, if you could read that. $1.0 # All right, so that's just kind of telling us that that did not work, and it's based on the idea that if you divide something by 0, the result is infinity, right? So it will do floating point division based on integer without throwing in exception, without crashing your program, but this is not a response that you want. So typically what you do is you have some kind of if statement. When might this happen? You're adding up a series of test scores and you want to calculate their average. Well, what if there weren't any test scores? Then your number of scores is equal to 0. So if you divided your total, which is 0, by the number of scores, which is also 0, then you're going to get the error. You would think that 0 divided by 0 was 0, but it doesn't work that way. Let's see what C++ thinks the answer to that is. Right. -1, # ind. Yeah, whatever. Okay, so if you're going to do some kind of division where you're asking for, to calculate the average, based on something, then you need to handle a special case. What if you did not have any data? Let's mimic that. I am going to delete these little bits of lines of code, but we're going to write a loop that adds numbers together. So let's declare a total, int total is equal to 0, and let's hold a variable that we want to add to our total. And then so cout enter score, or -1 to quit, and then cin into value, and while value is not equal to -1, then we go into our loop and we add that to our total. Total plus equals value, and then let's repeat these two statements. Now I've made a mistake here because this is adding to our total, but it won't let us get an average, because what do I need an average? What do I need in order to calculate average? Not only the total, but right, the number of entries. So anyways, we'll get there, but the first thing I need to do is to repeat this adding here. So I'm going to copy those two statements and paste them there. And that's what my code looks like. And so when I'm ready to calculate the average, you know, tell you what, let's make total a float rather than an int. Or it could be a double. But then down here we could do float average is equal to total divided by, and we don't have a count yet, so we're going to have to fill that in. And then we could see out the average. Average equals, end quote, arrow, arrow, average, arrow, arrow, NDL. So what I'm going to have to do is I'm going to have to create a variable called count, and then I will have to initialize it to 0, and I will have to increment it. So I guess above this while loop is as good a place as any, or how about up here at the very top? Int count equals 0. I need that, so I'm going to put a comment. This is what I just added, and I added it out of order. That's why I'm putting that there. And then inside my while loop, I need to add 1 to my counter. So count plus plus. I just added that line as well. So those are the two things. Now, run it and try it with some good data, and by that I mean enter, a series of values, and then try it again, just entering -1 to begin immediately. There were build errors. I don't see them. Error list. Oh. Apparently I have value defined twice. Okay. It's fine. I'll comment out that declaration. And apparently I have another problem as well. Nope, that fixed it. Okay. So enter some scores, 10, 20, 30, -1 to quit, and the average is 20. That's correct. Now if I run it again, since I didn't use integers, since I used floats, it's not going to crash, but the output's going to be lousy, right? -1, it'll say the average is equal to -1 $IND, which is definitely not what we want to see. So here, after we're done with our while loop, we're going to want to do a check. We're going to want to make sure that our count is not equal to 0. So let's do that. If count equals 0, or how about not equal to 0? And then let's do our open brace. And then tab this stuff over and let's put our close brace then. And if we wanted to, we could also print an error message, right? We could do an else. That would display an error message saying, there is no average. You didn't give me any data. The way it's structured right now, they just don't get an error. They don't get any message whatsoever. That's okay. maybe. I'm kind of wishing that we had an else. So, else, C out, arrow, arrow, no values added, so no average to display, backslash n, end quote, period. Not period, semicolon. One thing you might wind up doing, or that, you know, as a natural outgrowth of all this stuff, is if we came up with some good code for handling getting a value and validating it to make sure that it was within a certain range or something like that, you might stick that code in a function and then reuse that code over and over whenever you need to get some more input and turn it into a number. Now, I'm just going to leave that as a trailing thought. So checking valid date ranges is an example of data validation. I'm real tempted to dig into that. Nope, nope. Use some self-will. All right. Entering test scores, right? If there are supposed to be test scores, then we might set an upper and a lower range. You know, you can't score less than 0, and you can't score greater than 100. Or what if what if they allow bonus credit past 100? You have to consider that, but 1,000 wouldn't be a bad result, right? You know, so you might just have to figure out upon your specs which range of data would be acceptable. Comparing characters and strings. Now, I did a great big lecture about binary and decimal and stuff like that, but did I talk about ASCII? And the folks of y'all who just sat through Java don't answer that. Did I talk about ASCII?
I don't remember this.
Okay, so ASCII is how the data text that we type in. If we type in hello, then behind it all, it's stored as a series of characters. So pop open your favorite browser and go to hexed.it.
Yeah, we went over that.
Okay, and then I'm going to click new. Well, I don't even need to click new, but if I come over here and I type in something, hello, like that, then these are the hexadecimal values of these ASCII characters. And an H is a 48, and a E is a 65, and a C is a 6C, and so on. When a string is stored in C++, it has each one of these ASCII values stored in a character array, and then there's one last value, which is set equal to 0, which is known as null. And the reason for that is otherwise you have no way of knowing where the end of that string is, right? Because we might have two pieces of data, right? If we have hello and then we have another piece of data called world, and they were supposed to be stored in two different variables. Well, if there was nothing marking the end of one from the beginning of the other, then they would all blend like that. So a string in this language has both a series of ASCII values, and then it has a terminating null. That's what the terminating null is called, and that's when you have a 0, 0, like that. And then you'd have some more things stored in another memory spot, followed by another 0, 0, and so on. So when strings are compared, they are compared using their ASCII values. So A is less than B, is that true? It is, because the ASCII value of A is less than the ASCII value of B. Is 1 less than 2? Again, that's true, because the ASCII value of 1 is less than the ASCII value of 2. How about this? Is A less than 1? It's not, because if we went and looked at hexedit, you know, a capital A is 41 in hex, and a 1 is a 31 in hex, so that's actually like a 65, and I don't remember what that one is. But anyways, the 1 is less than the A. So, if you're comparing ASCII values, most punctuation and most numbers are less than the uppercase letters, and then the uppercase letters have ASCII values less than the lowercase letters. So if you were going to sort things, it would sort all the uppercase text first, and then all the lowercase text underneath it, which can be a problem if you're sorting names or whatever, and you're not sure whether it'd be good to have your data normalized in such a way that it was treated so that uppercase letters and lowercase letters were the same for sorting purposes. So strings are also compared using their ASCII values. If we do this, name 1 is equal to Mary, and name 2 is equal to Mark, which of these strings is so-called greater than the other? Well, this one, M is M, that's fine, A is A, R and R, and then K and Y. Which one is smaller, a K or a Y?
K.
K, so that means that name 2 is less than name 1. Apparently we don't feel much about talking about that a lot because we go immediately into this. The conditional operator. This is also known as the ternary operator because it has 3 components. Most of the operators we've seen have just 2 pieces. They have a piece of data before the operator, and they have a piece of data after the operator. That's why they're called binary. They require 2 operands. This one requires 3 operands, and the way it works is you have a question mark. The thing before the question mark is an expression. The thing after the question mark is what gets executed if the expression is true. And then the thing after the colon is what happens if the expression is false. So it looks a lot like this. Int temperature is equal to, and I say I have a 65 there. Okay, so then I could say cout, and then I'm going to have an expression, temp greater than 100, question mark, and if temperature is greater than 100, we're going to print boiling, else we're going to print freezing, like that. Now these parentheses are not necessary. I put them there just to make them absolutely clear that this happens first before the question mark. So if you did this, x is equal to temperature equals 1 colon 1, or wait, question mark 100 colon negative 100. What is x going to equal after this evaluates? How do you figure that out? It looks like gibberish. It looks like just a long bunch of junk. But what you got to do is you look at the thing before the question mark, and this is a logical expression. Well, according to our variable up here, is temp equal to 1? No, so it doesn't equal that. This gets executed. And so the 100 gets stored into x. So by the time this is done, x now equals negative 100. Now you can do some weird stuff with this syntax. But in short, this is what it meant. If temperature is equal to 1, then x equals 100, else x equals negative 100. That's what that meant. That code does the same thing. But what's kind of odd about it is that these don't just have to be little values like this. They could actually be entire expressions. Excuse me, entire statements. And that's what this PowerPoint shows here. That's a statement. That's not just a value. That's a statement. So they're saying, is x less than 0? If it is, then y is equal to 10. Otherwise, z is equal to 20. That's valid. It's valid syntax. It's kind of odd, but you just remember that it's like an if statement. If this is true, then this, else this. Let's go and tack that on up to the top of our main. We're going to ask them for a temperature, so we're going to need a temp value. Int TMP, cout, what is the temperature? In F, question mark. Let's read into TMP. So CIN arrow arrow TMP. And then we're going to have an output string. String output. And output is equal, excuse me, no double equals. Output equals temperature greater than 212 question mark. Boiling, end quote, colon, not boiling, end quote, semicolon. And then we could do cout arrow arrow, that temperature or that water is space end quote arrow arrow output arrow arrow NDL, like that. We didn't even necessarily need to store it in a temporary variable like that. We could have, I could just cut all of this stuff here from there to there. Cut that and replace the word output with that. Makes it harder to read. I don't like it for that reason. I'm going to undo that change. When I'm writing these ternary statements, these conditional statements, I like putting the if clause in parentheses, but it's not strictly necessary. But it is necessary when you write if statements, so I just like doing that. It makes it a little bit more readable to my eyes. So that's called a conditional statement, otherwise known as a ternary operator. So condition, question mark, whatever is executed here. This is the true case, else the false case. It says parentheses may be needed in an expression due to precedence of the conditional operator. When in doubt, use parentheses to make things clear. The switch statement. The switch statement lets you choose between several alternatives. Now we wrote a program that lets them type in A and D and Q and T. Here's what I want you to do. It's going to be kind of annoying, but suffer with me on this. Highlight all this stuff. Go to your program and where it says if choice all the way down to option is not supported, highlight all that stuff and comment it out with edit, advanced, comment selection. Alright, it's commented out. It did it differently than the other editors that I'm used to, where we put double slashes in front of everything, but that's okay. We're going to rewrite this code so that it uses a switch. The way a switch looks is like this. Switch followed by a variable, and then an angle brace, and then you put a case, followed by a value, and then you put a statement, followed by a semicolon, and then another case, and a value, and a semicolon. Now this is not showing something that's very essential, which are breaks in it. But here's an example of it. Enter your choice. Type in A, B, or C. CIN arrow choice. Switch based on that choice. Did they type in an A? Cout. You entered an A. Break. B, case B, C out you entered a B, break. Case C, C out you entered C, break. Default, you did not enter A, B, or C. Okay, so here we go. We have what they wanted to do stored in a variable called choice. However, switch only works on characters and not strings. So we're going to have to do something a little bit fishy, and I'm sorry for not having thought of this in advance. But what we're going to do is we're going to switch, parentheses, choice, and then square brace 0 in square brace. No, I'm feeling guilty about doing that. We're not going to do it that way. Instead, we're going to do char ch equals choice subscript 0. That gets the first letter of that string and stores it in that character so that we can then do a switch. And why is that necessary? Because in this particular language, switching and casing only works on integer data types, and characters are integers. So this would work. And then those after that, switch parentheses ch. Open curly brace, case, single quote A, single quote. Why are we using single quotes? Because ch is a character, not a string. Then value plus plus, semicolon, break. Like that. And then we had one for doubling. Case, single quote, D, end quote, colon. Value times equals 2. Break. Case T was our tripling code. Value times equals 3. Break. And then they had Q. Case, single quote, Q, end quote. C out. OK, done. Backslash n, end quote, semicolon, break. And then lastly, a default case, default, C out, that option is not supported, backslash n, end quote, semicolon. And then there'll be a closing brace that matches the open one, so just make sure it's there, right? And I don't like the way that it tabs these things automatically. See, Visual Studio tabs them kind of strange. So I'm going to highlight all of this stuff and tab it over one, but that's just my personal preference. This code should now behave exactly the same way as it did before. It's functionally identical. It's just structured in a way that may be easier for you to read once you get used to seeing case. What is the temperature in F? Well, it's 500. That water's boiling. Enter score, -1 to quit. Okay, we have a lot of stuff to do before we can actually get to the, okay, now we can do it. T for tripling, A for add, D for double, T for double. And then I type in some bad stuff and I start getting some error messages. All right, so anyways, that code is working. One thing I want you to see is that you can stack up multiple cases. What if we wanted to let them use lowercase letters as well as uppercase? We can just list multiple cases. I could do case, quote, upper case A, end quote, colon, followed by the word case, apostrophe, lowercase a, end quote, colon. Like that. And then I could add in a case, lowercase d, next to this case, uppercase d. Case, lowercase d. And then case, lowercase t. And then case, lowercase q. pause this. If anybody is trying to get this to work. So go to the Dropbox. Refresh your Dropbox if need be. Go back to assignments. And there's one called Sphere Density and Mass. There's a document there. Let's get that document open. And I'm going to download it. And you're not going to really be able to follow along, but you're going to at least see what I'm doing. Yeah, you could follow along. We have time. Come on, we have a whole 12 minutes. We can get this done, right? Okay, so open the document up, and you'll find some code on page 2. We would have to make a new project for us to be able to do this. There's also code on page 3, the same code in Java. So, yeah, I am going to make a new project. So I'm going to do File, Close Solution, File, New Project. And you guys have already done this in Java. You don't have to redo this part if you don't want to. I'm going to make a new empty project. I'm going to come over here to Source Files and do Add, New Item. And what homework assignment is this? This is homework 7, so I'm just going to call it homework 7, whatever. And then I'm going to take everything that's in that Word doc and I'm going to paste it. Not everything. Everything on page 2. And then I'm going to run it. And the program's not going to do anything yet. It's not right. But here's the way it's supposed to work. Enter the diameter of the sphere in feet. Okay, this is a sphere that is 5 feet in diameter. Do you want it made out of ice, aluminum, or gold? I want this one to be made out of ice. And there, we didn't get to see it do anything. Well, that's because it's not fixed yet. For one thing, we don't have our pause statement down at the bottom. So for you non-Macintosh users, you're going to want to put a system pause down at the bottom. System, parentheses, quote, pause. But the real thing okay, so there we go. Into the diameter of the sphere. And I guess that I made this easier for the C++ users because the code is already done. And then we enter a material. Now, based on the material and based on the diameter, it calculates the volume and it calculates the weight. So all that's already done for us. So the documentation is showing us some extra information, such as table sizes to try. If you want to try a golf ball, it's 0.14 feet in diameter. A basketball is 0.8 feet in diameter. An exercise ball that you find in the gym is 2.5 feet in diameter. So we could play with those values. You want to find out how much a gold marble would weigh, then we could type that in. But more importantly, on the 3rd page, the 4th page, the 5th page, wherever, once you get down here, you see the actual crux of the assignment. The customer wishes to change the program in the following ways. The customer wants different materials besides ice, aluminum, and water. So we would add some of the following choices, or we would add all the following choices. So if I run the program again, what is the diameter of the sphere in feet? It's a 1-foot sphere, and it's made out of ice. It weighs 28 pounds. If I run it again, see how to make it loop. But it's made out of gold. It weighs 600 pounds. Obviously, gold is a lot heavier than water, than ice. So here we have our list of materials. We want to add some support for them. So what would we do? We would go and we would add some extra menu options. Like, let's go ahead and do iron. So if you did all that business, you could come in here and we would need to add some more choices here. Do we want them on a new line? I don't know. 4 for iron. And then I would need to add a new bit of code down here to support that. So else if parentheses type equals 4 in parentheses, then the density is whatever the density for iron was. 491 pounds per cubic foot. So 491. So now when I run it, I have a new option in my menu. Right into the diameter of the sphere, 0.05. If it's made out of iron, that would weigh, that much, whatever. So that's that homework assignment. That's the way that's supposed to work. And I thought that there was going to be more setup to it because I forgot that for the C++ people, I'd already given them all this code. We were supposed to have to add that, and we were supposed to have to create all of this ourselves. But instead, when you go in, you're going to be adding on to this if menu, and you're going to be adding on to your print statement here, your menus here. Does that make sense? I know it makes sense for you Java folks, because you just did this in your other language. How about everybody else? Angel, that look good to you?
Yeah.
I'm going to call you out by name, why not? Alrighty, okay. Well then, we are done for today. What is coming up next? September 25th for an exam? Are we ready to have it then? That would presume that we're going to be entirely done with the chapter. I'd like to push the exam back to the 27th, but that is going to be the same day as the exam for you two Java folks. So 2 and Vincent, are you okay with having 2 exams in a row? Feel free to say, no, I don't want to do that.
It's okay.
It's okay with you? Yeah, you guess it's okay. All right. All right, so we're going to move it to the 27th so that we have extra 2 days to work on it because we're not quite done with the chapter. Oh, but we are so close to being done with the chapter. Maybe we could keep it at the same time. We've got 10 pages left. Yeah, we're done with the chapter actually. So let's not change the date of the menu. All we have left to talk about is we can look at switching case a little bit more, but then talk about blocks and scopes. So we are actually officially done with the chapter. So we won't change that. All right, let's make a Dropbox.
And so what day is the test?
25, Tuesday, next week.
So we're not changing.
We're not going to change it. I thought we had more left in the chapter than we did.
We can't access it now, right? Like, you haven't graded it?
The exam, you're not supposed to be able to access it.
Like, we can't see it, right?
I hope not.
Oh, I meant the like, under quizzes, it's not there.
You're right, you're right. Let me make it active and set the due date for it, just so it'll be a reminder. Yeah, I get your question now.
So it's like the start date today, and then take it.
Nah.
So it's just due that day.
Okay, please do get Chapter 3's quiz done remarkably fast, since we're already well done with Chapter 3. I didn't put a due date on it, but that doesn't mean you're not supposed to do it. It is worth credit. And then once it's graded, you can retake it. And now that we're pretty much done with Chapter 4, you ought to go ahead and do the Chapter 4 quiz as well. And if it will help you, I can put due dates on them. But then you'll be able to retake them anyways. So I'm not going to do them. Please just get the Chapters 3 and 4 quizzes due. Whatever you get done by Wednesday night will be graded so that you can look at it again by Thursday. Otherwise, I'll grade them as soon as I get them in. But if they come in on Wednesday, I'll get them to you by Thursday. If they don't, then I'll shoot me a text message whenever you get your quiz done if you want me to grade it on the spot. How about that? Okay, very cleverly I have two folders called BMI Calculator. Brandon and 2 put something in that one, reasonable enough. And then Brandon also got that one there. And 2 did was, so I can nuke that folder, right? Because you got it in both places. Okay. Sorry about that.
Get a Dropbox for today's lecture?
Yep, there's a Dropbox there now.